Hi, I'm Sarah. This is my mess and welcome to it. On this episode, we'll take a close look at a couple of interesting radios. We'll see they have more in common than the fact they each take a couple of AA batteries. There's this little gem which I'll call the pig radio, and then there's this one which I made from a kit. Both play decently and do what they're supposed to do. Before telling the story of what makes these receivers unique, let's see where they're all the same. This is a representative block diagram of an FM radio. The signal from the antenna is amplified, then mixed with another signal generated within the radio. This second signal is 10.7 megahertz removed from the tuned station. This means that when you're tuned into Hits 101.1, the second signal is ticking along at 111.8 megahertz. Coming out of the mixer is a signal at the difference frequency of the two signals going in. You guessed it, 10.7 megahertz. This signal goes to the IF or intermediate frequency amplifier. This is actually several stages of stable gain and filtering to amplify the signal and smooth out any amplitude variations, leaving just the wiggles in frequency. These wiggles go to the detector where they're turned into an audio-musical signal. Some detectors are sensitive to amplitude variations, which is why the signals are smoothed over in the previous stage. From here, the signal diverges. Some of it is sent to the AFC for tuning correction. We'll take a look there in a moment. Still more of it is sent to the audio amplifier, where several stages of gain will bring the signal up to a level where it will be able to power a loudspeaker. The part of the signal that goes to the AFC, or automatic frequency control, is to help the station stay tuned in. Since the detector is sensitive to frequency changes, we can use that in a feedback loop for this purpose. The AFC filters off the audio and provides a correction signal to the oscillator. This helps keep the tuned station within the 10.7 megahertz channel of the IF strip. Where these radios differ most from the rest of the world is in their IF frequency. Instead of the 10.7 megahertz frequency, these radios use a much lower frequency of 70 kilohertz. That's 0.07 megahertz. The significance of this is that the filters used can be smaller, part of the microchip itself that the radio is made from. Now that we have that under our hats, let's take a look at this radio. Based on the RDA 5870 FP chip, this is a really sophisticated piece of technology. The tuned station comes in on the antenna and sends it to the low noise amplifier that has a limiting action. This is a departure from the usual arrangement where the limiter is in the last IF stages. The converter block is another departure from the usual. Most converter blocks have one mixer. This block has two, and the differences don't stop there. The oscillator signal is split and fed to the mixers 90 degrees apart from each other. This is a special arrangement between the two signals. They are labeled I for in phase and Q for quadrature phase. These I and Q signals, now at the low frequency IF, are fed to a pair of programmable gain amplifiers. These further smooth and condition the IF signals for their trip to a pair of analog to digital converters. These turn the analog I and Q signals into digital numbers. From here they go to the DSP block. Here the FM signal is turned into a baseband composite multiplex signal and then decode the left and right channels out of that. Owing to the timing chart here, I can only presume that the switching method of multiplex decoding is used here. The DSP block has one more thing to do here, and that's to control the volume. The DSP block feeds to a pair of digital to analog converters. These DACs are special in that they enjoy an output impedance low enough to drive headphones. As part of the housekeeping, there is an RSSI or Receive Signal Strength Indicator to ensure signal quality. The FP version of this chip also has an RDS block for when the IC interfaces with a microprocessor. And not to be outdone, this radio has a quartz lock synthesizer instead of the simple ramp tune circuit we'll see next. Battery consumption is fairly light at 17 milliamps active and a scant 5 microamps in standby. And how does it play? Well, it's almost too much with the amplifier. Oh, and if you happen to get one of these kits, do yourself a favor and get decent earbuds. I happen to like Skull Candy. Okay, now let's take a close look at this little cutie. Based on the SC1088 chip, this is a basic ramp-tuned radio. Because we're driving a loudspeaker, we'll need an amplifier. The TDA2822 dual-channel amplifier will work nicely here. Though this IC will do stereo, we'll instead use the bridge circuit, driving both terminals of the speaker, each coming from an amplifier. This way, the peak-to-peak signal reaching the speaker is a little below twice the battery voltage. With the 8-ohm speaker, we can max out around 1/4 watt. Not bad for a couple of AA cells. Now let's take a look at how this thing tunes in tunes. Simply, the 68 nanofarad capacitor's charge here determines the spot on the dial. The reset button across the cap sets the band at the bottom of the dial. Hitting the run button causes the search tuning flip-flop to be set. This causes pin 16 to be pulled low through a current source. This causes the 68 nanofarad capacitor to slowly charge. This charge is applied to V101, which tunes the VCO. When a station is found, the signal strength line and center tuning cause the flip-flop to be reset. This also causes the AF line to be delivered to the searching tuning block. This forms a loop that keeps the voltage on the 68 nanofarad capacitor steady, keeping the station centered. This also causes the mute block to become uncoupled, where the audio appears at pin 2 of the IC. And if you don't like that station, a press on the run button causes the above cycle to repeat and find the next station up on the dial. While we're here, let's take a look under the cover a bit. Here we see the bottom of the board is fairly populated with many surface mount devices. The back cover is where the battery compartment lives. Also here we see a couple of screws holding a trim piece. Looking at the front reveals a plethora of screws holding on the trim pieces. I count a dozen, holding pieces that are usually glued. And if you're wondering about 2 of them, they're in the top up there, helping it to fit into its slots in the case. This has to have been a model that was over-engineered, but the final product is just cute. And this other little kit is just full of surprises in how good it sounds, though I can sometimes hear the DSP working on weak signals. Moving the radio usually improves things. This is because the headphone is the antenna. And there we have it, a couple of really surprising receivers. I'm Sarah, thank you for watching. If you can help a girl out, my PayPal is in the description below. Ciao!